LED is blinking with 100 millisecond delay. Now I change the delay. I simply go here. I had written some standard equations. I use those equations here. See, this is the standard equation I shown in the presentation how to make. I make this value like 250 value, and this will change the delay to 250 value now. Again, I zoom out. Let me build the code and write it and see what happens. Okay, the new code is being written. Let's get to the hardware. Let it write. Okay, it's written. Now you see that the delay has slowed down. It's now 250 millisecond delay. In this way, by doing these simple calculations, I had shown you here. You don't have to do this all the time again. You will simply use these standard equations that I have shown you in the code to generate any delay time you want with timer 0 of the PIC16F877A. Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how we can use the timer 0 of PIC16F877A microcontroller to blink an LED. So let's get started. So guys, first of all, before we move on to our programming and hardware, first of all, let me show you the basic mathematics you need to do to generate a time using a timer. So first of all guys, we will need to find out what is the overflow time of our timer, and then how many times we get overflowed to make our required delay. Like we want to generate a delay of 1 second with a timer, then we have to find out that how much time the timer will overflow with a selected prescaler to generate that 1 second delay. So for that we will need to do this basic math. So let's get started. So guys, you know that the crystal you have with the PIC16F877A is at the pin number 13 and 14 only. PIC don't have any internal oscillator, so you have to go with the external oscillator at pin number 13, 14. Whatever the crystal is at that point, you will use that frequency over here. I am using a 20 megahertz crystal, so the frequency is 20 megahertz. If you multiply 20 into 10 to the power 6, you get the frequency in hertz. Whatever this is, just do it by calculator. Now guys, for the frequency of CPU, divide the frequency of oscillator by 4. That is done by the internal architecture of the PIC. So it becomes 5 megahertz. Suppose if it was 16 megahertz your crystal, then it will become 4 megahertz. So whatever the value you have over there, you will divide it by 4. Then the frequency you get is the frequency of the CPU. Then guys, there is a prescaler table in the datasheet of the PIC. I will give you link to the datasheet. You can download the datasheet of the PIC16F877A. In that datasheet, you have this prescaler table, and we will set this prescaler values in the programming. Here you have options. Now there are bit values of prescalers. If you set bit values to 111 like this, option reg is the register, then you will get a prescaler of 256. So in my case, let me do the calculation with a 256 prescaler. I select this one. Okay, then you see how it works, and then we will go for the programming. I will show you in the datasheet how this works. Now guys, take a look here. Now F timer, that is the frequency of the timer, is the frequency of the CPU divided by the prescaler. So whatever the prescaler you select, you will write here like this, and the frequency of the CPU is 5 megahertz and the prescaler we selected is 256. See, so the frequency becomes 19531.25 hertz like this. Now guys, the T timer, the timing of the timer for one complete cycle for overflow becomes time is 1 divided by frequency, and frequency is 1 divided by time. They are inversely proportional to each other. So this is the frequency timer. Then time timer, that will become 1 divided by 19531.25. It becomes this. Then this is 51.2 microseconds. This is the standard time. If you want to skip, I am just trying to show you how this comes. If you want to skip all this, you can just directly use this time for one cycle. So now guys, the next thing is our timer 0 is a 8-bit register in the PIC, or by default we are using it in the 8-bit mode. Then guys, it means that maximum value it can have is 2 power 8 equals to 256. Or in the term of computer, it is 0 to 255. We also count 0, so it becomes 255 values from 0 to 255. So this means that timer 0 will have overflow by counting from 0 to 255 in 51.2 microsecond. It's 0 to 255. So it's like this. Okay, by counting from 0 to 255 in 51.2 microseconds, and in the previous slide I showed you how we got this 51.2 microsecond. So one overflow comes whenever it counts from 0 to 255 because it's a 8-bit register. So now the next thing is, now we calculate for 1 millisecond how many overflows will be needed. Now one overflow will take place in 51.2 microsecond, that is counting from 0 to 255 ends in 51.2 microsecond. Now that's the standard time. Now for our 1 millisecond delay, how much will be needed? For 1 millisecond is equal to 1000 microsecond. So it becomes 1000 microsecond divided by 51.2, 19.53125 overflows. So we need like 20 overflows for 1 millisecond delay. Now suppose we want a delay of 1 second. So for that 1 second is equal to 1000 millisecond. Then what we do simple maths. We multiply 19.53125 multiply by 1000, we get 19531.25 overflows like this. Now this is like a standard. This equation I will also tell you how to make a function in MikroC, so you don't have to do these calculations again and again. You simply write those three calculation lines and this will be done on auto. So the next thing is, now we have to see that we need 19531.25 overflows. But the point is we also have prescaler. Now let's see how the prescaler will affect this. Now we had selected a prescaler of 1:256 like this. So I had selected from here 1:256. This is given in the data sheet. If you get 1112 option rec value F0 option rec bit 0 1 2 3 1 1 1, your prescaler is set to 1:256. Now this means it will take 256 instructions cycles to complete one overflow. Now that's how it's gonna affect. So this means overflow needed for 1 second delay with 1:256 prescaler will become 19531.25 divided by 256 76. So all we need are now 76 overflows if we select a you can say if it select a prescaler of 256. So if you select a prescaler of 8, then simply divided by 8 over here. If you select a prescaler of 2, then divided by 2. Higher the prescaler, lower the overflows will become. So that's how this is gonna work. So we will do the programming on MikroC, and I will make a standard equation for it for you. That will be easy to use. Now guys, what we are going to do here is that we will use our PIC microcontroller and an LED. So let's connect them. So this is our PIC16F877A having 40 pins. It's a DIP version, and this is an LED having 2 pins, one longer, one shorter. You know, the longer is the power, shorter is always a ground. And we will need a safety resistor. It can be from 220 ohm to up to 500 ohm. Higher the value, lower the brightness of the LED will go. I'm going to use a 220 ohm resistor because it works very good with the 5 mm crystal type LED. So let's do the connections. So the longer pin I name it as power, the shorter pin as a ground. You cannot shuffle these two pins, remember. Longer is always the power, shorter is always the ground. And the ground pin will directly go to the ground of your PIC like this. And for the power pin, you will connect it to the one end of the 220 ohm resistor like this. Then from the other end of this 220 ohm resistor, you can use any available digital input output pin of the PIC. I'm going to use the pin number B5 because it's available. That's all. Now we move to the hardware. Let me show you the hardware I'm going to use here. So guys, this is the hardware over here, simple as that. One of these LEDs will be used, and this is our PIC16F877A, and that is port pin B.F5, and here we have our 220 ohm resistor, and there is a crystal that is a 20 megahertz crystal. Simple as that. Now guys, let's get to the MikroC for PIC so we can start programming. Let me zoom in so you guys can see better. So guys, you can see that MikroC for PIC version 7.2.0 is the one I am using. 7.5.0 or other latest versions are also available. You can use those versions. Latest is always better. So let's get started. Click on File, New Project. Here this window pops up, New Project Wizard. Click on Next. Write the name of the project. I write Timer 0 Tutorial by Learning Microcontrollers. That's the name of the project I wrote. And PIC16F877A is the microcontroller I am using, and this is the path where the files will be created. And the crystal you have at the pin number 13 and 14 of your PIC16F877A, write that value over here. I have a 20 megahertz crystal over there, so that's why I wrote 20 here. Click on Next and Finish. Now guys, this window pops up. Before you do anything else, first of all, save your work, press Ctrl S. Work is saved. Now guys, we have an LED at pin number B.F5, that is B5. So let's initialize it. Trace B.F5 equals to 0. This command is like pin mode output or input command in Arduino IDE. So here it is trace B. Trace is a register which will define the direction of the pin, and B.F5 is a pin. 0 means it's an output, 1 means it's an input. So LED pin is always output. So here the initial state of the LED must be off. Initially the LED must be off. So sorry, it's F5 like this. So initially the LED is off, simple. Now we give some initialization delay. This delay is not necessary, but I always suggest you give it in the one time loop for the smooth functioning of your programming, like this. Now this command over here, port B.F5, is like a digital write command, low or high in Arduino. It's like port B, port which pin B.F5. It should be either input or out, or low or high. So 0 means low, 1 means high. So by default it's off. So by default the LED is off. Now we have our LED initialized. Now we will have our timer pins, timer registers initialized, which we are going to need in the programming. So first register is the option reg register. So I write here. In the newer version, you have to be careful with the capital and small letters. Option underscore reg equals to, now give it in the binary or in hexadecimal. I suggest you always give it in the binary, it's more clear. 0B 1 2 3 4 5 6 7 8. So there are total 8 bits. So 1 2 3 4 5 6 7 8. Now let's get to the datasheet and see what this registers do. So I go to the datasheet. I will give you the link to this datasheet in the description of this video, so don't worry. So this is prescaler. This is INTCon. Now this is the option reg register. See that it has total of 8 bit. This is for the prescaler, PS0, PS1, PS2. That is what that table refers to. See, PS0, PS1, PS2. These 3 bits over here. They are the first 3 bits of this option reg register, and they are used to set the prescaler value. Now take a look here. PS0, PS1, PS2, whatever the digits you set here according to this table will set the value. So in our case, we are using a prescale of 1:256. So we will need to set them to 111. So let's get to the MikroC and set them to 111. So these are the 3 bits. First 3, 1, 1, 1. So now our prescaler is set to 256. Prescaler 1:256. It's set. Now the next thing is we will need to give enable to the internal pull-ups. You can go without them, but I always suggest you pull the internal pull-ups up for the timers. So this is the RBPU port B pull-up enable bit. It means internal pull-ups are disabled. Okay, so we need to disable the internal pull-ups because by default you can see that bar over there. We have to remove this bar, so we will send a 1 to this pin as well. So for that purpose, that is bit 7. So again, go to your MikroC for PIC. We need to disable the internal pull-up. So this is the bit. This is the bit number 7. See that's why I gave it in binary. You can also convert it to hex as well. Whatever the hex value come, you can give it that as well. Mostly that hex is used. I place the value here. See, this is the hex value. You can also send 0x87 as well. So this will also do the same. So our prescaler is set to 256 and internal pull-ups are turned off, disabled. Now the next register also gives some initialization delay, not necessary, but I always suggest you give it in the one time loop. 10 will do fine. Now the next register is the INTCon register. We need to disable that completely. So for that, I write INTCon equals to 0x00. All the pins have been sent to 0, or you can also use it in the binary form 0B 1 2 3 4 5 6 7 8, like this. Count them: 0 1 2 3 4 5 6 7 8. That's fine. Now the INTCon is 0. I give some initialization delay. Let me show you what the INTCon does. So in the datasheet, again, go back to the datasheet. Now this is the INTCon register. This is used to enable the interrupts. See the global interrupt pin, then we have peripheral interrupt enable, then the timer overflow interrupt enable, then the external interrupt pin, that is pin number B0 of the PIC16F877A, and then the RB port change interrupt. Then you have different type of interrupt bits coming from the different sources. You disable all of them by giving this complete port a 0. See, we have sent 0 to all of these bits. See, now INTCon is 0, option reg is prescaler is set using the option reg, that is 1:256. Now we can go to our forever loop to use a timer, but for the overflow bit we will need an integer. So for that, let me use an integer int. I take any integer, like I take it like OF timing, OF time, that how many times the overflow should take place. So we go to the forever loop here, while one, start writing from here, and overflow, oh sorry, forever loop ends here and starts from here. Now inside it, first of all, we had calculated that our overflow time, how many times we need the overflow is 76 times for 1 second delay. So let's first of all generate a 1 second delay. For that I write this, I take this register, overflow timing equals to 0, we use a for loop, and then this is less than equal to the whatever the time overflow time is generated, that is around 76 times we need the overflow for 1 second delay. Now I end this here. See, now starting from there, ending from there, this is the time we calculated in the by using the formulary. You saw that in the presentation I had shown you the formulas we used to generate these overflows. Now I built this code, check for errors, because for loop, okay, that's perfect. So now the next thing is, inside it we write if intcon, now we are looking for the timer flag, intcon dot t0. Now here we are using timer 0, you can use timer 1, 2, etc. by changing this. Overflow flag is 1. If the timer has overflowed, then it should increment the off time by equals to, or sorry, make it just plus plus or equals to off time plus 1. Now it's increment the overflow time, and then if intcon dot timer 0 overflow is equals to 0, it becomes 0, that the timer has overflowed, then it goes out of the loop, loop ends. Then the port, that is the LED we need to blink, port B dot F5 equals to 0, it becomes 0. Now this is a 1 second delay. This over here you can make a function out of it. This is our 1 second delay using the for loop. This is the overflow timing we calculated in the presentation. I showed you how to calculate this, and then that we are using here. Now these are the timer flags. Now if the timer 1 flag is high, then it will keep on incrementing the overflow time, and as soon as it becomes off 0, then it simply turns off the LED. Now we turn on the LED. So there our for loop ends. So I write for loop ends. Now the next thing is, now for the on loop, now this is for the just we commented, so you guys will have ease. For off time start, and I write here, you can make a function out of it as well, that simple as that. For off time now and here, and now for on time we will start from here, for on time start, and then for on time there will be an end like this here, for on time end. Now what I do is that I copy this from here, copy it till here, from here to here, and paste it inside it. Now for the on time, simply replace the 0 to 1. Now it will again take 1 second, it's 76, and it will turn on this LED again. Now I build this code, let's burn this into the microcontroller and see what happens. So this is our PIC16 programmer tool. Click on file, import hex file. This is the program hex file we just created. Click on write. Okay, the new program is being written. Let's get to the hardware and see what happens. So this is our hardware over here. Let me write the new code and see, does it generate the 1 second delay or does it work at all? Okay, I power up the circuit using the PIC16. I click on. Okay. Okay, that's 1 second. That's perfect. See, it has generated the 1 second delay successfully. Now this is how the timer works. But the problem is here is that now suppose I want to change the delay time, then I have to do all this calculation over here again. For that we make some standard equations. So you will simply don't have to do all of this. You simply use those equations that I will make right now. So go back here. Above it you take some more variables. So I take one as integer calculation 1, cal 1, another as integer in time. Now this is the in time that you will update for changing the delay time in time. Then I make it like integer time. This is our time, final time. Now what I do is that in the one time loop I write few lines here. I write in time is equals to whatever the delay you want. Sorry, copy this variable name must be correct. Okay, in time, whatever the delay you want, you will write in milliseconds here. Just multiply whatever it is in seconds to 1000. Like I want to generate a delay of 0.5 of half a second, then I write 500. 500, this means the delay time in milliseconds. That's all. Now this will be the delay we want to generate here. Instead of doing all those calculations, I will simply use these standard equations now. Then I make it calculation 1 equals to. Now here you can see that what we do is that we simply multiply the time we want to generate by 19.53125. How this 19.53125 came, none of your concern right now. Now we only want to generate the delay. So whatever we want, we write here. So what I do is that I simply enter this equation. So I write here that call equals to 19.53125 multiplied by in time. Now in time is the time that we want. So we want 500 millisecond delay. So that will be entered over there. We only have to update this now to change the delay instead of doing all those calculations. So now the time, that will be our final time, equals to whatever the calibration 1 value is divided by 256. Now this is the prescaler. Whatever the prescaler is, you will write that over here. See, now I had selected the prescaler 256. See here. Now see the table. If you want to change the prescaler, whatever the prescaler you select, you will write that here. Okay. So this is simple as that. Now what I do is that this is done. Now instead of writing overflow this here, these values here, I write this time here. Now this is it. Instead of 76, I use this time, and here too I use this time. Now the delay will be 500 millisecond. Because we had written here 500, then we go 100, 200, and we write different delays. So it's built successfully. I click on write, update the code. Now that blinking speed will slow down. Let's get to the hardware. Let it build. See, now it's 0.5 second. Simple as that. Now we again change the delay to 250 millisecond. So I go here, I simply change this value, I make it 250. Now it's 250. I zoom out, build the code and burn it. I click on write. See, now you don't have to go through all of these calculations again and again. You only have to enter the prescaler and change the variable value. That's all. The new code is being written. Let's see what happens. See, now it's fast. It's 250 millisecond delay now. See, we again change the delay to 100 millisecond. I make it 100 like this. Now it will do the calculations on auto by itself, because PIC microcontroller can do the calculations. Any microcontroller can do the calculations. So why don't we make a use of it? Click on write. Okay, let's see what happens this time. The blinking will go even faster. See, it's even faster. So guys, in this way you can use timer 0 for generating delays in PIC microcontroller, and this has a lot of benefits because you have the timer flag here. You can do a lot of things from this. So guys, if you still have any questions, you can ask in the comment. And thank you very much guys for your time and your patience. I hope you learned something from this video. We'll see you in the next video. Have a nice day.